Now let's work some examples. I want you to try part A on your own. Pause the video, and when you resume, I'll have the solution. So for part A, if we shift f of x right 3 units, then we'll end up with the function 19 minus 5x. Looking at B, f of x is the absolute value of x. We want it to shift it left 1 unit, so we're going to add 1 to x. So G is absolute value of x plus 1. For part C, shifted right 2 units, x minus 2. So G of x is f of x minus 2, and f is a square root of x function, so we're square root of whatever's inside the parentheses. Square root of x minus 2. Now let's put together the symbols and the graphs. Here we have the function f of x is 1/2 x minus 1. We want to shift left 2 units. So our new function, left 2, means we're going to add 2 to x. You can almost think about using the opposite sign for horizontal translations. If we're going right, which is the positive x direction, we need to subtract. But if we're going left in the negative x direction, we need to add. And for this symbolic expression, our function g just turns out to be 1/2 x. When we grab points from our graph and we shift them left 2 units, we get another line, but this time the line goes through the origin. So our y-intercept is 0. And I forgot to make a table, so let's make a table. Try part B on your own, pause the video, see if you can shift it, get the correct shifted function, and draw your graph. So now in part B, does your graph look like mine? Shifted right 3 units, and also our function g, x squared minus 6x plus 10. Now we have two functions, f and g. F is the darker graph, g is the lighter graph, and we need to determine the shift that happens. It's a horizontal shift. If I start with f here, I have this point at 2, 0. If I need to get to g, I see that I went 3 units in the left direction, and for the reason I can say 2, 0 becomes negative 1, 0. And I see that that works for all of the points. To go from F to G, I have to go 3 units to the left. For B, I'll take this point right here at the origin, 0, 0, and to get to the same point on my G graph, we need to count. Now I do need to be careful because I have this point over here at negative 2, 0, so I want to make sure the same feature, this same U shape here, gets matched up. 0, 0, I need to go 1, 2, 3, 4 units in the positive direction, to the right. So we've got to shift to the right by 4, and we're moving this important point over. Again, noticing the features of the graph. The yellow spot here, I have a U sitting on that 0, 0, so I want that same spot on my function g, which is why we don't stop at 2, 0. That's only the first part of the function, not this U shape. And that concludes our work on translations. If we're doing vertical translations, we just add or subtract on the end of the function depending on the direction. So adding moves our function up, subtracting moves our function down. But for horizontal translations, it does not work that way. The signs are opposite. So if we are translating to the right, we need to subtract on x, and if we're moving to the left, we need to add to x. When we talk about quadratic functions, we'll see this same idea again with finding the vertex of our quadratic function.